Alright, so here we are with lesson 8, and we're going to look at something called significant figures, and this is extremely important. Not only do they ask you about this topic on the Regents exam, but it also comes into play when you have calculations in lab. So this is an extremely important section. It's definitely more important than scientific notation and accuracy and precision, etc. So it's a pretty important section. So let's quickly run through and take a look at significant figures. And basically, significant figures is a way to handle measurements of the uncertainty in a measurement. So when you make a measurement using, for example, a graduated cylinder or a balance, not all the numbers are certain because you're probably, if you're not doing it, the machine is actually estimating the final number. So if you have a balance that only goes to the hundredths place, obviously you can measure it out to more than the hundredths place. So the machine itself, the instrument itself, is rounding off to the hundredths place. So there is some uncertainty in every single measurement. So let's take a look, for example, at the ruler. Now notice the arrow is right here. So it says we know for sure that the object is more than 2, we'll assume these are centimeters, but less than 3. So this would be 2 but less than 3. So let's take it a step further. We know for sure that the object is more than 2.8. Now let's take a look. Where do they get 2.8 from? Well, this is 2.1, 2.2, 2.3, 0.4, 0.5, 2.6, 2.7, 2.8. So you know it's a little bit more than 2.8, but it's less than 2.9. Now here's where you're going to make the estimate. What is that second number? Well, you can approximate it. So this is 2.8, this is 2.9, so you'll see that this is 2.85. It looks like it's a little bit before that, so we're going to say it's 2.84. So we estimate it as 2.84. So that 4 is the uncertain number. It's an estimate. We really don't know if that's a 4 at the end. And that's what significant figures is really all about. Again, reading a ruler is important because you're going to be using that in several labs. Let's look at a graduated cylinder. Graduated cylinder is a piece of equipment that you use to measure how much of a liquid you have. In other words, the volume of a liquid. And you've probably already seen this before, but when you measure a liquid in a graduated cylinder, which is a tube, the water level is never flat. It's always curved, and that curve is called a meniscus. And you read the level based on the bottom of the meniscus. So you're going to read the level right here. So this is 25, and this is 30. So obviously, this is going to be 26, 27, 28, 29, 30. So you'll notice that it's between 27 and 28. And I'm going to say it's about halfway. So I'm going to say it's 26, 27. I'm going to say it's 27.5 would be the approximate reading on the graduated cylinder. And again, when you're reading a graduated cylinder, you want to be at eye level. So you don't want to be standing and the graduated cylinder's on the lab bench and you're at an angle because it's going to be very difficult to get a reading, an accurate reading. Alright, so how do we determine what numbers in a measurement are significant, meaning are certain? Let's take a look. And these rules obviously you're going to need to memorize because they don't appear anywhere on your reference tables. So when you have a measurement, doesn't matter if you're measuring mass, volume, density, whatever it is, any number that is not a zero, all non-zero numbers are always significant, no matter how many there are. So for example, in this number, all of these numbers are significant. Now, if you have a number in scientific notation, the only ones that are significant are the numbers that are in the mantissa. So we know that there are only 3 significant figures in this number. Those are probably zeros after the 3. The second rule is what I like to call sandwich zeros, or they call them captive zeros. Zeros that are between non-zero numbers are always significant, and it doesn't matter how many zeros. For example, you see this is 40.7. All 3 of these are significant. If there were 10 zeros here, they would all still be significant because they are sandwiched between non-zero numbers. Another example, 87,009. These zeros are significant, so all 5 of these numbers are significant. Now we get into 2 other things, what are called leading zeros. And again, I'm not sure if your notes, if I updated this or not. If this is not what's written on yours, cross out what you have and just write this sentence here. Leading zeros are not significant. A leading zero are zeros that are in front of non-zero numbers. Basically, any number that you see that's 0 point something, these zeros are never significant. They are just what we call placeholders, meaning that they are there to make sure that the 9, 5, 8, 7 fall into the correct column. So the only significant numbers here are the 9, 5, 8, 7. It doesn't mean you get rid of the zeros. They are necessary. They're just not significant. Same thing here. These zeros in front are leading zeros. They are never significant, so the only significant figure here is a 9. Again, you don't get rid of the zeros. They are just there as placeholders. Trailing zeros are the most difficult. Trailing zeros are zeros that are at the end of a number. And you can see 4 examples here. And here, basically, again, if this is not what is written in your notes, cross out what you have and just put this in because I kind of simplified it. Basically, if you have trailing zeros are only significant if there is a decimal in the number. It doesn't matter where the decimal is. As long as there's a decimal in the number, the trailing zeros are significant. So if you look at this, that's a decimal. That makes these zeros significant. So this has 4 significant figures. Same thing here. Notice all these zeros? They are all significant because of that decimal right there. If you take that decimal out, those zeros are not significant. Number 4, again, notice this, no decimal. Only number that's significant here is the 2. Doesn't mean you get rid of the 3 zeros. It just means they are not significant. They're basically estimates. Now, notice the difference between this and this. All I did simply was add a decimal. That makes all 4 of those significant because that decimal means that I measured to this place. Whereas here, I have no idea if I measured this. So this has 4 significant figures. And that's something that you have to be able to do, is to determine significant figures. And we're obviously going to practice that. So here are a few to practice, and let me see if I can get the pen to work. Probably not, but we'll give it a shot. Okay, here we go. I don't know what that is. It's thunder. Get rid of this. Where that came from. Okay, so let's take a look. And again, go back to the rules. I'm not going to go through the rules that are applied, but here's the number, 1,020. Now, that's a sandwich zero, so that 0 is significant. Is there a decimal? There is no decimal, so that 0 is not significant. So the only significant figures are the 1, the 0, and the 2. So there's only 3 significant figures. Next one. Notice there's no decimal. These are trailing zeros. So those zeros are not significant. So there's only 2 significant figures. I'm going to underline the significant figures in each of these just to save a little bit of time. Notice the difference between these two. Now I added a decimal. All 4 of these are significant. So this has 4 significant figures. I'm sorry, this is just not working out with the pen. Trailing zeros, these are trailing zeros, are significant if there's a decimal. So all of these numbers, 12 and there's 4 zeros, are all significant. That is, I think, 6 significant figures. Leading zeros, never significant. So the only significant figure there is 1, so there's only 1 significant figure. Again, the decimal makes these trailing zeros significant, so all 4 of these are significant. I'm going to, again, underline all the significant figures. These are trailing zeros, but there's no decimal, so only the 1 and the 2 are significant, so there's only 2 significant figures. These are trailing zeros, so they are not, leading zeros. These are trailing zeros. They are significant because there's a decimal, so those 3 are significant. All of these are significant because that 0 is a sandwich 0, so that's 5 significant figures. Now here's a tricky one. This is a sandwich 0, so it's significant. These are trailing zeros, but notice there's no decimal point. So these zeros are not significant, so only the 101 is significant. You don't get rid of the zeros that are at the end. They're just not significant. And that's how you do significant figures.